So I'm going to start by letting the minister to talk a little bit. He had to be there sitting without being able to say anything while listening. So I don't know if you want to address some of the things that were said. So please.
Well, good afternoon. Thank you very much for the invitation. I would like to thank Professor José Francisco Rodrigues for the invitation. It was very, very interesting to listen to your interventions. So I would like to start. I'm the Minister for Education, Science and Innovation, and I would like to start by mentioning some of the remarks that were made by Jean-Pierre and also by Nguyen. Jung. I apologize. I apologize for that. Concerning the relevance of mathematics for the development of the brain development. So mathematics is very, very important since the early years of education, since the very beginning, and so we should put a lot of focus on that. So in Portugal, we have several programs on computation, computational thinking, on logical thinking. Just 2 days ago, I had a meeting with several professors from here, from University of Porto, and also from University of Minho, and from INESCTEC. And that have a very, very interesting project that is the INSICO Association on computational thinking. And that is, of course, all dimensions of education are very important, arts and humanities, all dimensions. But mathematics develops some dimensions of the brain, of thinking that we should invest in since the very beginning. And it was also mentioned by some of the interventions that the skills that we develop related to mathematics will also be very important for employability in the future. And so almost 20 years ago, I think in 2007, I published a paper in higher education about the importance of mathematics for employability. And then I was interviewed by a newspaper, I think it was Expresso, and I told the journalist that we should have a marketing strategy for incentivizing families and their children to study math, because once you have best grades in math, we found a relation between the grades that you get that young people get in math, and then their future employability, the type of programs that can follow when they go to higher education. And so that dimension of mathematics is very important for the development of the human being. But mathematics is also, as you have mentioned here, is a universal language. Is a universal language that tries to decode the hidden order that we have in the universe or in the nature. And so it is a way that humanity has followed to try to understand the world where we live. So these examples that Pedro Camanho gave, that with some mathematical relations we can find some patterns that we have in nature or in the universe. It was something that came from imagination, even before the Greeks. It was like an intuition to understand the mysteries of the world and of life by means of mathematics. And that was pursued by Joy as as a sport, as you mentioned, but also sometimes with a purpose, to try to get specific answers to specific problems. So I think that this balance between, so we can value mathematics and study mathematics just for the sake of knowledge, just for the sake of joy. Mankind has been doing that for 1,000 years, and we still do it. But as several interventions also remarked, we can, and Eugenio was very, he was very persuasive, I think, in showing that we could have a very short, so you could look at mathematics as providing solutions to specific problems, and result in innovation. You know, I prefer innovation to technology because I just think that technology is a form of innovation. So by using mathematics, and mathematics is most of the times at the basis of technological or innovations, technological solutions or innovations. And so that is also something that when we think about our scientific system, we have to consider. So we have to provide the space to protect the pursuit of knowledge by the sake of knowledge. And that is crucial. Most of the disruptive innovations, and several were mentioned here, come from research, from discoveries that at the time were not useful. And João Ribeiro also mentioned that in a very interesting way, with mention to NSA, the assessment of NSA to the zero knowledge. And so that is a very good example, but we have many. And so in a scientific, in the organization of our scientific system, we have to preserve that. So if we don't preserve that, we will eliminate I would say, the main source of innovation, the main source of knowledge. But then, and it is interesting that Jean-Pierre mentioned Francis Bacon, that the idea that through knowledge, useful knowledge, you can control nature. That was the focus of Francis Bacon. That in the Enlightenment that you also mentioned, and that is, although we should pursue and protect knowledge for the sake of knowledge, in fact, it's unavoidable that when we look at the progress and the progress that we have made, at least since the Industrial Revolution, that the relation between the progress of humanity since the Industrial Revolution is based on science, is based on knowledge. And so, of course, from that it comes that we have this expression that the recent Nobel Prize, Joël Mokyr, uses a lot, the useful knowledge, and that we should value. So useful knowledge, the idea that to invest in science, we can get knowledge that is useful for society, is something that we also should praise. And we should do it because societies expect that scientists, that researchers contribute to well-being, to individual and to social well-being. And if we want to mobilize more resources to science, if we want to mobilize more tax revenues to science in a democracy, we have to show to society that it's worth to do it. It's worth to do it. that is a dimension of any scientist that we should develop more and more. Of course, when we are in a small circle, we should focus. We may give more focus to the knowledge by the sake of knowledge. But when we talk to the society, we have to emphasize the benefits that society gets from the investment that is done in science. Just to finish this first intervention, because I believe that I will have a second.
Yes, you'll have a second.
Second chance.
Depends how long you talk now.
Okay, but I would like to mention AI Squared, the new agency. But I would like to stress the relevance of education and science in a world that is more and more complex. We live in a world that is more and more complex. Interestingly, so we have climate change, we have more and more extreme events and unexpected events. So uncertainty, there are some interesting measures of uncertainty, and if you look at them, they have been increasing significantly in the last decade or so. So you have more extreme events, and they are more interconnected, and so you have dynamics in the economy, in politics that are much more difficult to anticipate. So we have more uncertainty, and when you have more uncertainty, you need more knowledge and you have a more complex world, you need more knowledge, you need more education to get the good solutions. I'm not using the term optimal solutions, but good solutions, to have good solutions. And Jean-Pierre also mentioned populism. When we live in a world where populism is increasing, also in Portugal. And when you have an increase in populism, it's very easy to convince people that you can get simple answers to complex problems. And if you can get simple answers to complex problems, maybe you don't have to invest so much in education and science. And so it's also very important to be pedagogical about the fact that to get solutions for very challenging problems that we have, we need more investment in science. That is something that we have to emphasize. Just probably what is one of the main drivers, I would say the main driver of uncertainty in the last at least 5 years is technology. So technology is a solution, of course. So it's the response to challenges, to problems that mankind trying to find a solution. But currently, with this new revolution that we are living, namely on artificial intelligence, technology is itself a driver. It's itself a source of uncertainty. So if I look at what we expect, for instance, for the labor market, I have to focus on the impact of digital technologies, artificial intelligence on labor demand, for instance. And then what do I have to do in the education system to adapt for the changes that we are going to face in labor market that we are facing now, that we are currently living in the labor market. So technology that is human-made and that at the beginning was an attempt by mankind to control nature, to reduce uncertainty, is currently the main source of uncertainty. And that is the last thought for the first intervention that I would like to.
Okay, thank you. So I would like to introduce two parallel themes. So we saw here on the talks the two sides of mathematics: the applied, very directly applied mathematics, and the fundamental side of mathematics. We saw that Professor Nguyen mentioned that it was done for fun. It's also for curiosity. And sometimes I don't think we understand that by doing that, just pure curiosity, we are digging into the deep secrets of the universe. I believe that's why mathematics is so applicable. Because even if we're doing it without not applying it directly, we're trying to understand something very deep inside the universe. And I would like you to comment on that, but I want to introduce several things so I don't speak again. So I don't have to introduce, so we're going to go on around. So I want to ask you if you understand, if you agree with me, and that work on fundamental mathematics is very important to be prepared for things that we cannot predict now, for unseen things in the future. And so we should have always some humans working on this. And so that's one thing I would like you to comment on this. And then applied math is easier to sell than fundamental math, of course. And I would like to ask, I would like to start with Jean-Pierre Bourignon, how to convince governments to finance basic scientific research. And I know it's not an easy answer, but I would like you all to talk a little bit about how do you see these things that I just mentioned.
Well, of course, it's a very basic, fundamental question and a difficult one, especially at times where there is not so much money available, and therefore priorities have to be set. On the other hand, I think one thing which we need to really never forget is the time scale of things. And for example, one thing which makes a huge difference is the quality of education that you receive. I personally was so lucky to have had, my parents had basically no education, but had absolutely wonderful teachers. And they were wonderful for two things. First, because what they knew it for good. They were really competent. But at the same time, they were always encouraging the pupils to really look further and to continue and so on. So I think for me, the first scale we need to keep in mind, and I'm not forgetting your question, is really, if we don't invest in quality education, which means training the teachers properly. And at the moment, because of the incredible challenge that education is facing with artificial intelligence, retraining the teachers. And at the moment, I'm speaking just for my own country, so little is done there that I'm terrified, because I could see with my children, but I even see with my grandchildren. I have already grandchildren who are 27, so I can even see them going through a cycle, that the decline in the quality of teaching has been tremendous. And they were not in a very poor district or anything. It's just a fact. And so I think for this first consideration about scale, if we can manage to keep quality education, that's a long-term effect which really will have an impact. Now, to convince governments to keep supporting basic science, I think for me the main concept is the concept of continuum. That is, it's just not possible to separate one from the other. And there are so many examples where when you take out one of the elements which was fundamental to get to the next stage, I try to give one because it's such an obvious one, and really with a short time scale. Google was created in 1998. Could you imagine this? For us, it's an obvious thing. It's not obvious at all. It came very late. So I think this notion of continuum is very important. That is, believing that you can forget for some time all this because now we have enough and so on is just wrong. Because if you want to keep the continuum alive, there will be always new things, new Googles occurring, new concepts which will be appearing. And so, therefore, that's the main argument. To believe that you can compartment things is just not true.
So, João?
Do you want me to answer both questions or just one?
The one you feel more comfortable, the ones you feel more comfortable.
Yeah, of course.
I don't think I've much experience with trying to convince governments.
No, I don't. Yeah, let me start with I guess the first question you asked was about like whether we agree that pure math is important to like for us to then like maybe later on realize that this concept that we actually thought about like 50 years ago.
Yes, because do you think it's even when it's not immediately relevant?
Of course,
it's underlying. It gives us information about something that's going on deeply on the universe.
Yeah, of course. I mean, I totally agree with that. And you see this happen at different times. So for example, I give an example where you went from something where you were, people were just exploring it. People are trying to understand the fundamental limits of the universe. It's a very pure question. And then maybe 30 years later, some applications arise because computers got, they became faster. Now it's actually, and not only that, but actually people started then thinking about like the clever ways to actually make things practical. But then I didn't tell you about, because I didn't have time, about like the stuff that goes into these solutions, which was stuff that was maybe developed 150 years ago. Maybe you use multivariate polynomials over large finite fields. In order for you to study this, it doesn't. You don't invent polynomials to solve that. You know how to solve it because you already had polynomials. You already understood them, right? And the way you understood it, like you didn't really
You're using too scary words.
No, I'm just saying, like, I mean, replace polynomials by just any mathematical concept, right? And the idea is just that people know how to apply it because they spent decades just playing around with these concepts for fun or just for just because of their own curiosity. So yes, this is my answer to your first question. My answer to the second question. I don't think I'm qualified to answer that. What Jean-Pierre said made a lot of sense, and I think that kind of. Sorry. Yeah.
No, it's okay.
No, I was just going to say that I mean, making governments aware of this continuum, right? I think is the way to go.
Okay. Yeah. I also wanted to do this other thing because I agree with what Minister said. It's in a democracy you have to explain to people what we are doing, and maybe we should do a better job at explaining the importance of what we do. And also another thing, sometimes applied math, and we're working on applied problems that raises questions that then out of curiosity people try to solve. But so I'm gonna jump, but you're our last word. So Professor Nguyen.
So as a pure mathematician, I could like to think that the fundamental mathematics is important, right? Because I'm a pure mathematician myself.
Yes.
And of course, so when I discovered some kind of conservation principle or whatever, I think that this is something which is universal, right? Like Einstein once said that an equation is for eternity, right? Something like that. And about funding for mathematics or for research. So when I was mathematics professor, I was always very poor, unfortunately, and I couldn't get much funding from the government or I don't know from where. And it is a general situation in France, unfortunately, compared to some other countries like China. I think China, they did it really very well.
Yes, they're improving it. Yeah.
I mean, they have this kind of very good policies since already 30 years ago or so. That's why they could develop really very fast. So I read somewhere that China is one of very few countries in the world where a university professor had a higher income than a doctor or a lawyer. Okay. And it is very rare, and so they really care.
As I told you, I'm learning Chinese, so now I'll start learning more.
and the fact is that when so like already 7-8 years ago, I was a visiting professor in Shanghai for some time, and I was paid twice what I was paid in France already at that time.
Okay.
So I mean, really to not only mathematics but to develop fast the science and technology, you have to invest money in R&D. And unfortunately, in countries like, I don't know, in France, it is only about 2 point something percentage of the GDP. And in fast developing countries like China or Israel and some other countries, it's more than 4%, 5%. In Korea, it is very, so in Korea, they invest like something like 700 billion of dollars in the robotic program. It's just one robotic program, 700 billion. In France, the whole France 2030 is something like 50 billion. So it is just a fraction of what they invest in just one thing. So I think that France, I don't know about the other country in Europe, is missing a principle, unfortunately. And it is very difficult to change that because the politicians, they are thinking about politics, not about long-term development. They're thinking about winning the next election. Yeah, so unfortunately, I do not have solutions to propose for our.
Okay. So, Eugênio.
Okay. So let me start with, I don't know, like in the role of pure mathematician in analysis. So one of the issues that the government will face is that many people here will be depressed. At least me, I will be depressed if you don't invest in the real mathematics. I'm joking, but the fact is that if we somehow correlate or relate the countries that have investments in fundamental science and then see the innovation, you will see that in fact there is a relation. So if we cut these fundamental, you will face after some time, maybe there is a lag, but it's measurable. It's not just mathematics is good and we should, no, it's measurable in some sense. This is one point. The other point about practical, it's true. In fact, I face many times this issue because all these solutions, in fact, are short-term, like you saw every year, and we have, I'm going to present like 20 products, so it's not just these things, it's a lot of things, it's a big team. So we face several things, that is, we look to mathematics and try to apply these mathematics to real problems. But we know, in mathematics, sometimes we need to assume that. And for us mathematicians is very nice because put us in the setting that we are good at. But when we are facing to solve a real problem, we need to think, no, I cannot assume that. So real applications push real mathematics deeply, okay? So we always playing this double role, in fact. And this is very nice. As a mathematician, that is one of the reasons why I do apply mathematics, because it's challenging, okay? So it's, in fact, for me, more easy to do partial differential equations in some sense than try to solve correctly, not by approximation, correctly, a real problem. It's very, very difficult, in fact, to solve correctly the things. So that is one point. Now, like with the role of president of SPM, so Portuguese mathematics, let me talk a little bit about education. So, and also with the role with related with these applications. So, as you imagine, we have here control towers and information. So naturally, the agendas are going to finish in June. So it's natural I have a lot of products and potential. How can I use it? So it's quite natural to think I will apply these control towers to other applications. Let me tell you that you saw one control tower, I have like 4, and one has some screens that we have real data with LLMs and so on, getting information about uncertainty. Because for logistics, it's really important that I know everything. So we have some screen with everything that appears in the news. We cross over and do scores and show what is happening and so on. So I was thinking, okay, let us apply this to other areas. For example, to health, like an issue that is infections and all these issues. And we have some kind of data. It's more or less difficult to get it, but we have. And then I was thinking, okay, let's look to education. So education in one point has something that I think we should work on. That is, we do not have measurable ways or correct ways to measure how education really evolves and how it's the state. So we don't have so much real data, let us say. It's not like going to a factory where I have a sensor and I have values. You see? So one of the issues is very, very difficult in education. So our minister has a very tough job to do. Why? Because there are a lot of stakeholders. You have professors, you have students, you have parents, you have a lot of issues. And all of these persons have different interests. You have jobs to take care after and so on. But data for us to understand precisely and to compare if, for example, an exam is really comparable to other, we have very little ways to do it. We have, for example, PISA. PISA is one example, and PISA everywhere in the last years has decreased, okay? For example, we were talking about technology. If you look a little careful, what are the countries for there is no decrease? What is the reason? Is technology? What do you think? No, it was books. The use of intensively manual books, okay? All the others just decrease in PISA, okay? So the problem is very, very complex, in fact. So it's not easy to decide which or what is relevant. And one of the points is this one. I don't know how to do this, but it will be very nice if we have more ways to measure the impact of measures to education and so on. Thank you.
Okay, so
Okay,
I will start with the second question. And to be honest, I think that most governments don't need to be convinced about the value of science. And on the other hand, I think we'll never succeed explaining the value of science to governments that don't believe in science. So it's a lost cause. So what I think it's really important is to explain to the public in general, especially as Professor Jean-Pierre Bourguignon explained, that we are living in that time where we have misinformation, where people get the news from social media instead of reading proper newspapers. We need to engage with the public. We need to explain the value of science. We need to engage more with museums. We need to reach young kids. I think this is important. They need to understand the value of the investment that is done in science. I think during COVID that was an opportunity to explain, because I think people were very happy to realize that there was an ERC project that resulted in the vaccine. So this communication should be something that we should focus also in trying to engage the public. Regarding the first question, honestly, I think that it's a mistake to separate basic science from applied science. I think this is something that can divide the community in a time that we need to get the people together. I think even Pasteur said that there's not such a thing as applied science. There is science and its applications, same way that we cannot separate the tree from the fruit. So I believe in that. And I think that there's nothing more practical than the good theory. So I believe that what is important is really to have synergies between different scientific fields. I believe that I gave a few examples. So we are able to progress in some of our research due to developments in mathematics. I think we should promote a closer relationship between biologists, physicists, engineers, mathematicians. I think this is what is critical, because real progress often occurs at the boundaries of science, not in just one specific field. And as I've mentioned, mathematics for me is what unifies all these fields.
Okay, thank you. So, as I promised, last word, the Minister.
Thank you very much. It's very kind of you. I have some good news to Guilherme. Well, first, we have already implemented that in last year, and we have tests, model tests, and they are comparable, so they allow to follow the learning outcomes of students and the learning outcomes per school, per cohort. And so that was an innovation that we introduced in the system, and that will allow us to compare students. So exams are comparable. They use the same methodology as PISA, and so that was something that we implemented in the first year, because we know that is crucial to identify to follow the learnings of students. And also, I also have good news because we are implementing a structural reform in the education system, in the science and also in the education system. Is a very comprehensive reform that will reformulate all the information systems. It is being implemented. It is going to be monitored by OECD. We have an external and independent monitoring of the implementation of the reform. It's the first time that is going to happen. So we really want to be transparent and to have high standards. So in the end of 2027, OECD is going to publish 2 reports, one of education and another one on higher education and science. And the focus on the administrative dimension of the reform is on data. To have real data, administrative data, linking all the databases. So we are certifying the information systems. And that will be a paradigm change in Portugal because we have very good outcomes in education if you look at what we have done in the last 50 years. But we have a lot of potential to improve because the Ministry of Education doesn't have management based on data because it doesn't have an integrated information system. And so it's very difficult to manage.
Okay.
But it's changing. It's changing. The final message that I would like to leave is that so we are launching the national debate on the priorities for research and innovation in the context of the implementation of the new agency for research and innovation that will have a multi-year budget, a 5-year budget. And because we have a multi-year budget, we have a 5-year budget, of course we have to have strategic planning and we have to define priorities. I think that is quite evident. You all agree. So if we do it year on year, it's as we have been doing that for decades, you just define the next year based on the previous year. So I have been saying that we use a backward-looking planning mechanism for science in Portugal. Okay, that is very strange because science must be forward-looking. And so when you have the multi-year budget, it comes with the need to plan and to define priorities. And I would like to tell to this community that it's very important that you participate in that debate. Of course, we are going to be very open, and we know that fundamental science, mathematics is very important. I think I was very clear about that. But in this debate, it's very important that you participate because I've been telling the community the final document that will define the contract that will be signed between the government and the new agency, that will be accountable for the results that we are going to have in 5 years, in 2031, will be the result of the participation of universities, research centers, all the community. It's not the government that is going to define the priorities in the office, okay? That was, I would say, the paradigm, but it will not be like that. It will be, of course, in the end, it will be the government that will define, but will be a decision based on a report that is public, transparent, and with the participation of all the community. So I can tell you that, of course, for mathematics, we will have scholarships, funds for projects and all that, no doubts about that, but the role of mathematics and the importance of mathematics, and I really thank Professor José Francisco for inviting me to have the opportunity to tell you that, is that, of course, we value very much fundamental research, mathematics, but you need to be vocal about that because it's something that we cannot take for granted. Thank you very much.
Okay, thank you. So now we have some time. I think I forgot my cell phone over there, but I think we have some time for a couple of questions, maybe from the public. Okay. Obrigado, Daniel. Luis Antunes from the Computer Science Department.
Yeah, so good afternoon. Thank you for your excellent talks. So I have just two comments. The first one is for João. So one of the authors that you have in your presentation, it was my supervisor, Lance Fortno. I just asked him, was there any application on the interactive protocols with multiple verifiers? And the answer was, it was just for fun. I was never expecting to have these applications that we have nowadays. But the fun fact is that nowadays we have this diploma in the parliament where to verify the age for the social networks, they are planning to use zero-knowledge proofs, which is really fun to have this in the parliament. So the second, I have just a story regarding AI squared. So when I came back from the United States, I applied for a grant. And then Amilcar Cernadas, he was in the mathematics panel of the Science Foundation, and he kicked my application to electronic engineering. And later he talked with me and told me, oh, the application was really good. There are lots of money in electronics engineering, so you can get money there, and you can leave the money in the mathematics for the pure mathematics. And he was right. So the way I see the AI square is just like this. So at the moment, I do my research in the company. So and I have PhD students, and I have grants from ANI close to 2 million euros, something that I would never get in FCT. So this connection between FCT and ANI through a square, I think it's really, really important. And if we have to kick people to the other side, to ANI, so we can leave the money for fundamental research in physics, in mathematics, I think that's the way to go. Otherwise, in 10 years, we will not have fundamental research to do applied research. If we kill the engine of the fundamental research, we will not have applied research in 10 years. So it's really a good idea, but we need to kick people to the other side. Okay.
Okay, so I think that your question is for two people.
Yeah,
so first João,
yeah.
and then.
I guess, Luis, I guess, thank you for the comment, and thank you for asking Lance about his result. Let me also say, you mentioned the multi-prover thing. That also, that's kind of this. It's a nice. I'm going to say this at a high level, but this for fun research into this more like on the computer science side, also ended up disproving some very important conjectures, like one-nominal algebras and stuff like that. Okay, but. I'm not sure if Luis had any questions for me specifically.
No, it's just a comment. So you should add on your slides that we nowadays are using zero knowledge in our legal system.
Yeah.
So the application, it comes down into incorporate a deep mathematical concept in a legal framework, which is surprising, at least for me, to find it there. I would never guess that someone from the legal side would know zero knowledge proofs.
Yes, I think that's surprising. I'm pretty sure there's been a lot of lobbying there because my feeling as okay, so I'm a theorist, right? But I do have contact, people that actually do cryptography that matters, and I feel that somehow the European Union has had some not so great decisions about privacy and cryptography in the near past, right? And I hope things don't go that way. But
so in fact, what we do in the company is privacy and I think applications. So things like a private set intersection, deep mathematics, but with practical applications. But we use deep mathematics. We have students that are doing the PhD in theoretical computer science in a company environment. So it's.
Let me also. I'd like to just say a word. Like you mentioned this thing about you applying for a grant here, then you being kicked to electrical engineering, right? I just like to very quickly share my experience as someone who came from the U.S. 3 years ago, right? I was first at Universidade Nova, and I joined. Okay, I joined as like new faculty, and you need to get money to not have a group, and this is just going to be a comment on the system as it is, which is me. Even though I'm doing something that perhaps within mathematics, I'm lucky because it's quite trendy and it's easy to sell. Okay, but it's still basic science. Within the Portuguese funding system or within like the European funding system, I have basically two options. Either I have very short-term Portuguese, FCT funded projects for like that give me maybe money for like a year, right? Or I have the ERC, right? And there's nothing else in between, right? And to me, I mean, within an ERC grant, I mean, sure, there's merit, whatever. There's also a lot of luck involved. So it's a lottery. Like I can also, I have some other opinions about the amount of money, but I don't think it should be like this, right? Because right now the ERC is really the only option, I guess, someone has in basic science to really build a team in I'd say the proper sense of the word, instead of just having like random people here and there. And that's it. That's all I want to say.
Okay.
Very quickly, just to say that AI Squared aims at get this continuum. It's just from fundamental science to applied science to more innovative projects. That is one of the, I think it's one of the main goals of AI Squared. And also that currently FCT, in fact, it funds many very diverse projects, okay? And some of them are top-down, many of them are top-down and very arbitrary. Okay? Without public discussion, they are decided. I haven't decided even one in my office, okay? But we have many going on that were decided in the office of the Minister, Secretary of State, I don't know, I don't care. But we have many that were defined top-down for that area, for that people, for that research centers. And that is the way, so it's when we have money, public money that is decided top-down, you have to justify that publicly. You have to be completely transparent. But because when you give money to a group that probably it's worth, you have an opportunity cost. I'm an economist. You have many other alternative uses for that money. And you have to show that that is the best application of public money. And so if you look at the budget of FCT, they have many projects that are not fundamental science, not basic science, and some of them are not science.
I think that most of them should be in ANI. Most of these projects should not be in FCT. They should be financed by ANI because they are applied. And if we do this, we leave the money from FCT for the fundamental research that we really need.
And I may tell you that some of them should not be funded.
So, any other questions? We have a shy audience. So if you have no questions, I'm gonna ask the panel if there's anything you would like to add just before we finish.
Yeah, maybe one thing which for me is a bit terrifying, because I think I really don't know how to really object to that, although I'm totally in total disagreement with it, which is one of the arguments which actually you can even find in a conference by the Vice President of the United States some years ago, but not so many years ago, saying that actually we are under a dictatorship by people who have the knowledge and impose this to others. And of course, indeed, some of the challenges we face impose that we make some decisions and we take some action. In particular, climate change is a good example. And as you know, presently the official position of the United States is that climate change is a joke. We all know it's not a joke. And so to me, it shows that the relation of in particular, the world of universities, the world of research with the public has to change. Because you cannot have such a statement for which you don't have really a systematic way of proving that this is not true. That is, indeed, if you have to take a tough decision, which actually have an impact on basically everybody concerning climate change, it's not because this is a dictatorship, it's because it's absolutely needed, because what's going to happen is going to affect everybody very deeply. And in one sense, one example I want to give about climate change, which maybe is even more spectacular than the others, although it's coming up, slowly but systematically, is the increase in the level of oceans. Because for some countries, it's going to be an absolute killer. And of course, for a number of cities which are close to the ocean or to the sea, it's also going to be. And even a country in Europe like Netherlands, the interpolation is that within 15 years, 30% of the country will be underwater. Of course, if you manage to protect yourself, you will not be underwater. But you imagine the massive investment which will need it. And this is not something you can just ignore, because it's going to happen. So for me, the basis for this is to think, how can we transform this statement into something that we can object to in a concrete way? And my one sentence on this, which I think a dimension on which probably universities worldwide, at least in the Western world, have not thought about, is how much can the university contribute to people in the middle of their life, not only in the initial training, but also in the permanent training. Because then people will relate to universities as something which improve their own life along the way. And we know that the number of people who are going to need retraining is massive. And of course, for universities, it's a new way of looking at what you have to deliver as training, which means a lot of effort, a lot of thinking, a lot of retraining within the university. But it looks to me, if we are not addressing this to have a much broader group of people to which the university and the research system improve their life, then we are in big trouble.
That was a very good remark. I don't know if you want to. No, it's okay. It's an amazing way to end this meeting. So we have reached the end. Not quite. We'll see. But so we are closing the formal, let's say, meeting, which allowed us to remember that mathematics is not only a fundamental discipline of knowledge, very important, but also a powerful engine of innovation, collaboration, and progress for society. And we should add education is very important. And also I'll add something else to what Jean-Pierre said, that Professor Brignon just said, that it's critical to start thinking, to start teaching critical thinking. I think there's a lot of lack of critical thinking. But I would like to renew our sincere thanks to all the speakers. It was an amazing afternoon, okay, an amazing way to honor Pi and mathematics. And a special thank to you, Minister of Education. It was very interesting to have you here. And on behalf of the Faculty of Science and the organizing institutions, which I'll recall are the Lisbon Academy of Sciences, the International Center for Mathematics, and the Center for Mathematics of the Universal Porto, I thank everyone here for the presence at this celebration of the International Day of Mathematics and of Pi. I don't know if there will be pie downstairs, but I'll another kind. I want to invite all to a port of honor that will be served downstairs, and there's also a special room we have with the first 5 million digits of pi on the wall. So if you want to check if your birthday date is in there somewhere or cell phone, please join us. So thank you all for coming. Thank you, and thank your speakers.
Cover
Não sei se depois it was interesting because you mentioned breaking, I had some copies.